Hey y'all, Data Guy here, and today I have a video for you where I want to go through a kind of hidden problem that has arisen with the rise of vector databases, which is the silent degradation problem and embedding drift. If you upgrade your embedding model without re-embedding the documents that are already sitting in your vector database, what happens on the surface is nothing and there's no errors, and your RAG pipeline will keep answering questions, but it'll just get worse, a little more with every query in exact proportion to how much of your index is still on the old model. That's embedding drift, and it's one of the hardest RAG bugs to catch because the system is designed to fail silently. And so if you picture, a support bot that's been answering how do I reset a user's MFA device correctly for months, pulling the right document into context every time, but then someone swaps in a newer, better benchmarking embedding model, points new writes at it, and doesn't touch the 2,000 documents already indexed under the old one, because nothing is forcing that decision. And the bot, again, it won't crash, but it'll start pulling a vaguely related billing FAQ into the top slot instead, maybe, and pushing the actual answer down past the context window, and the response that eventually comes back will be generic and confidently wrong. And again, nothing broke. That's the problem. It won't spike your error rate or trip up a runtime alert. It'll just show up 3 weeks later as the chatbot got dumber, and by then, no one will remember that the embedding model got bumped. So today, I want to talk about the migration playbook that prevents that with dual indexes, a gradual cutover pattern, and a smoke test that you run before flipping production's traffic. So without further ado, let's get into it. So before I get into how to fix embedding drift, why does it actually happen? It happens because two different embedding models will produce vectors in different incompatible mathematical spaces, and a vector database has no way of knowing that. So an embedding model maps text to a point in high-dimensional space where distance is supposed to represent semantic similarity, but the exact geometry of that space where any given concept lands or what close numerically means is something that each model learns on its own during training. So two models never learn the same space even if they output the same number of dimensions. And same dimensionality also doesn't mean compatible geometry. So you can compute a cosine similarity between a vector for model A and a vector for model B, and the math will give you a number back, but that number won't mean anything because you're just measuring distance between two spaces that were never aligned. It's like measuring the distance between a point on a map of Boston and a point on a map of Tokyo at the same coordinates and calling it a real map or real trail. And this is why mixed index degrades instead of crashing. You query with the new model against old model vectors, and the similarity scores you get back are just noise, semantically meaningless numbers that occasionally rank high by coincidence, and their degradation tracks directly with what percentage of your index is stale. 10% stale, small hit, 60% stale, and you're serving wrong answers most of the time. And the mistake you'll normally see is teams treat an embedding model upgrade like a dependency bump. New model scores higher than the benchmark, drop it in and you're done. But it isn't a drop in replacement unless you also migrate every vector it touches. Model version isn't a detail, it's load-bearing metadata, and if you don't track it, you have no way of knowing which parts of index are safe to search. Now, before you actually execute a migration strategy, there's one single practice that can make every one of these possible and easy for you, which is tagging every vector at write time with the exact embedding model version that produced it. So not making it an optional field, but a required part of your write path from day one. And this will be the difference between a migration you can reason about and one you're flying blind on. With a version tag on every vector, you can always answer the question, what percentage of my index is on the new model right now, with an actual number instead of a guess. And that number is what drives every strategy I'm about to walk through, right? It's what tells a gradual cutover router how much to trust the new index, and it's what tells a lazy migration worker which documents still need attention. And the second piece of groundwork worth knowing is having in place a fixed set of test queries paired with known correct documents, something like 50 representative questions and the document ID that should come back for each. And this becomes your baseline recall number, and it's what you can then measure every migration strategy against. If you skip this later, you can still migrate an embedding model, but you'll be doing it without the ability to prove whether it actually worked. So the first strategy is the easiest conceptually, which is the full reindex, right? It's just take every document, you run it through the new model, and you replace the old index, and there's no mixed state or no query time logic waiting old versus new. The practical pattern that makes this safe is to build the new fully re-embedded index as a separate collection sitting alongside the old one rather than overwriting vectors in place. And that gives you two things: an instant rollback path if something's wrong with the new index, and a clean way to avoid downtime. So you keep production pointed at the old collection the entire time the new one is being built, and once it's fully populated and validated, you cut over atomically in a single alias swap, not a gradual transition. And most vector databases support exactly this kind of collection alias pattern for zero downtime cutovers. Now, the real cost, and where people talk themselves into skipping validation, is cost scales linearly with corpus size, and it stacks two ways. You have the embedding API cost and the processing time. For a few thousand documents, it's trivial, it's seconds and pennies. For a multi-million document corpus, it's hours of processing, and on a per token pricing model, it's a real line item that'll need sign-off, not a silent background task. And if you don't build the parallel collection, instead try to migrate in place, you either lock writes for that entire window, or you serve against a partially migrated index, which recreates the exact silent degradation problem that we're trying to solve here. So full reindex is the right call when your corpus is small enough that cost and time are close to trivial and you can comfortably run two collections side by side during the swap. Once you're at hundreds of thousands or millions of documents, though, you'll need something with a gentler resource curve, where the next two strategies come in. Now, the second strategy I have for you is the gradual dual index cutover migration. So basically, you have two indexes with a gradual cutover, and the strategy exists for the case when a full reindex is too slow or too expensive to do it all at once. So you run both the old and new indexes simultaneously and route queries to both and shift traffic gradually while the re-embedding happens in the background. So what this looks like in practice is the old collection will keep serving on the original model, while a background job re-embeds the corpus into a new collection at whatever pace your rate limits and budget allow. And in front of both of them sits a router that queries both collections on every request and blends the two result sets using a cutover weight, call it alpha, representing how much trust currently goes in a new index versus the old. Alpha starts at 0, there's all trust in the old index, and then it climbs as migration progresses. Because every vector carries that version tag from the setup step, you can compute exactly what fraction of the corpus has migrated at any moment and drive alpha directly off of that number rather than off a guess or a fixed calendar date. And one detail also worth building into the router is once a document exists in both collections, the merge step needs to deduplicate by document ID and keep whatever version the current alpha weighting favors rather than letting the same document get scored twice and distort the ranking. So expect a real but bounded drip in retrieval quality right in the middle of this transition, right? Roughly the point where the corpus is half migrated is where the blended results are the messiest because you're mixing two differently weighted, differently shaped result sets. And that's a normal part of the pattern. It's not a sign something's broken. It's why it's worth watching your recall numbers throughout the migration rather than only checking them at the very end. And the dip is going to be bounded and invisible, which is the whole value of this approach, overloading a mixed index to grade blindly with no instrumentation at all. So this is the right strategy when your corpus is too large to re-embed it all at once economically, but you still want a controlled, watchable migration timeline that you can set and tune. Now, finally, our third strategy is the lazy re-embedding on access option. And this takes a different premise from the first two strategies. Instead of migrating on a proactive schedule, you re-embed a document only when it's touched, and you spend the migration cost across natural traffic instead of pinning it all up front. And this is the strategy to reach for when your corpus is large and your access pattern is skewed. Maybe you have a small fraction of documents that get retrieved constantly and a long tail that barely gets touched at all. So if that's your traffic shape, lazy re-embedding means your hottest, most queried documents will migrate almost immediately just from normal usage, while the rarely accessed tail migrates slowly, which is fine because it's barely being served anyways. And the pattern relies on that same version tag. On retrieval, check whether a document's tag matches the current model version. If it's stale, you still return the result using its existing vector for that request, but you queue that document ID for background processing because you don't want to block a live user response on re-embedding. And then a separate worker drains the queue asynchronously, re-embeds the new model, and writes the updated vector back in place so the next retrieval finds it already current. And a gap here that's worth naming is documents never get retrieved, never get lazily migrated, potentially forever. So if you can't be confident that your cold, rarely touched content is genuinely low value, pair this pattern with a slow background sweep running at low priority to guarantee full coverage on some longer timeline, rather than leaving that part of your corpus stale indefinitely. It's also worth being clear-eyed. This adds permanent complexity to your retrieval path, a version check on every result, plus queue infrastructure that doesn't exist before. So it earns its keep on large access skewed corpora, but not on a corpus small enough that a full reindex would finish in under a minute. Whatever strategy you end up picking, don't flip full production traffic to a migrated index without validating it first. This is a step that teams typically skip or rush, and it's the one that will catch embedding drifts before it ships, right? So use that fixed set of test queries and known correct documents from your setup, version controlled rather than kept in someone's head, and check two things before cutover. One, recall at K is the expected document showing up in the top results. Second, and this is the check a lot of smoke tests will skip, compare actual rank positions and similarity scores against your pre-migration baseline, not just a binary pass-fail. So a document that used to rank first and now barely squeaks into rank 5 has technically passed a recall check, but it's telling you something's off with the new embedding space and it deserves a look. So set a hard threshold, right? Recall can't drop more than 2 or 3 points below baseline and fail the migration automatically if it does, and then spot check edge cases deliberately too, right? Short documents, unusually formatted content, anything in a secondary language, because an average across your test set can look perfectly healthy while quietly hiding a systematic failure in one category of content. So treat this smoke test as an actual gate in your migration process, not a sanity check. Before an alias flips, before a cutover weight reaches full trust in the new index, a smoke pass has to happen, full stop. And that's it. Those are really all the strategies I want to talk about today. Embedding drift happens because different embedding models produce vectors in incompatible spaces. Mixed index degrades retrieval quality silently with no errors in direct proportion to how much that index is scale. So these strategies will all help you make sure that that doesn't happen to you, right? So full reindex, right, for a small to medium corpus where you can re-embed entirely pretty cheaply. Dual indexes with gradual cutover is right for large corpa where the full reindex is too slow or expensive. And then lazy re-embedding on access is right for very large access skewed corpora paired with background sweeps so cold documents don't stay stale indefinitely. So whatever you choose though, tag every vector with its model version at write time, keep a version smoke test with known correct answers, and gate every migration on recall to stay within an acceptable band of baseline before production traffic touches it. If you do that, embedding model upgrades will go from really hard to diagnose RAG regression to a routine migration that you can run without a second thought, which is the dream for everyone. So hope you learned something. Hope you have a great rest of your day. Data Guy out.